Good day everyone. Today I want to explain to us how we can get some trigonometric ratio of some special angle. When we talk about special angle, what we mean is angle 30, angle 60 and angle 45. So special angle are angle 30, 60 and 45. So we want to look for the trigonometric ratio of each one of these angles. When I talk about trigonometric ratio, I'm talking about the sine, cosine and tan of each of these angle. So we are doing this because some problem, you will come across some problem in examination and you will see this sine, cos, tan of the angles will be given in root form. So how do you solve that problem? How do you get angles of each one of these with those square roots? That is what I want to teach us today. So let's start. So what we are going to do for the first two angles, that is angle 30 and angle 60, what you are using to get that is equilateral triangle. We are using equilateral triangle. Equilateral triangle is a triangle whose three sides are what? Are equal. That is, this side is equal to this side is equal to this side. Meaning that if all the sides are equal, it means all the angles will also be what? Equal. And for 360, for the sum of angle in a 360 in a triangle is 180 degree. So we are going to divide 180 by 3. So when we do that, each angle of equilateral triangle is 60 degrees. Take note of that. Each angle of equilateral triangle is 60 degrees. This place is also 60 degrees. But because I need angle 30, I'm going to divide this 360 60 degree here. I'm going to divide it into 2. Meaning this angle will now be what? Angle 30. This second place will also be what? Angle 30. And another thing you need to know if you want to use this to get tan, sine and cosine of this angle for 30 and 60. After you have gotten successfully draw your equilateral triangle, the side are given 2 here, 2 here, 2 here. We use the same 2 because the three sides are equal. Now because we have divided this side into 2, we have divided the angle into 2, this same line that divide the angle into 2 is going to divide this side into 2, meaning here will be 1 and here will also be 1, but from here to this place is what? Is 2. So we just need only one side of the triangle for us to solve our problem. I'm bringing one side of the triangle out. This angle 90, this side, I'm using this side, this is 2, this angle 60 degree, this is 1, and this is what? 30 degree up. So how do we get this side? You use Pythagorean theorem. This angle 90. Using Pythagorean theorem, you get this side to be root what? Square root of 3. Now, this is now what we use to find our sine, cosine, and tan of the two angles. So let's start with the 30 angle 30 degree first. Let's look at sine 30 degree. So sine 30 degree using this triangle. This is angle 30. Sine is what? Using our primary knowledge of what? Also catua. This is sine. Sine means opposite over hypotenuse. So this is angle 30. The side opposite that is facing angle 30 is the opposite. This is opposite and this is hypotenuse. Meaning sine 30 is 1 all over what? 2. Opposite over hypotenuse. That is that. Then we go for cos 30 degree. Cos 30 degree. Cos is what? Adjacent over hypotenuse. So this is the angle we are still dealing with. So this is the adjacent and this is the hypotenuse. Meaning it's going to be square root of 3 over 2. Then the next thing is tan 30 degree. So tan 30 degree, tan is what? Opposite over adjacent. So this is opposite, this is what? Adjacent. Opposite over adjacent, that is 1 opposite over adjacent, 1 root 3, 1 root 3. So if you rationalize this, you are going to have root 3 over 3. So we have done for angle 30, sine of angle 30, cosine of angle 30, and tan of angle 30. So we are now going for angle 60 degree. So we are starting with sine 60 degree. Sine 60 degree, since we are using 60, this is angle 60 degree. So the opposite, we are looking for sine, opposite of hypotenuse. The side facing angle 60 degree is the opposite. Then we are having opposite over hypotenuse is root 3 over 2. Root 3 over 2. If you observe at this point, root 3 over 2 is the same value that we have for cos 30. So sine 60 is the same thing as cos 30 degree. Take note, it's an important trigonometry function that you need to know, or identity that you need to know. So the next thing we take is what we are dealing with is cos 60 degree. Cos 60 degree, cos is what? Adjacent over hypotenuse. Adjacent over what? This is angle 60. This is the what? Adjacent. This is opposite, but we are dealing with adjacent over hypotenuse, which is 1 over what? 2. And you can see that this is the same thing as what? Sine 30 degree. This is the same thing as sine 30 degree. Sine 30 degree is 1 over 2. So the last thing about that is tan what? 60 degree. And what is tan 60 degree? Tan is what? Opposite over what? Adjacent. Opposite over adjacent, which is equal to root 3 over 1, which is the same thing as root 3. So the next thing we want to find now is the sine, the cosine, and the tan of angle 45. So we are still going to use a triangle for us to solve that problem. But the triangle we are using in this case is going to be a right angle isosceles triangle. What I mean by right angle triangle is that one of the angle must be 90 degree, and what I mean by isosceles triangle is that the two other angles must be equal, because for isosceles triangle two sides are equal, and apart from angle 90 the other angles are also what? Equal. So that knowledge is what we are going to use to solve our problem, because for us to have one angle to be 45, it means, and if it's right angle, the other angle will be what? 45, since we need 45 degree. So this is a right angle isosceles triangle. This is equal to this, making it isosceles triangle. So if here is equal to this side is equal to this side, then the base angle will be what? Equal. That is a law that has been established, that base angle of isosceles triangle are equal. So this is 45 and this is 45. Now, unlike in this equilateral triangle, when we use 2 and 2, in this place, the two equal sides of the isosceles triangle, we are going to use 1. Then meaning that by using Pythagorean theorem, we can find the third side. And if we do that, this side will be square root of 2. So now we have the complete side of the triangle that we can now use to find our sine 45, cos 45, and what? Tan 45. So let's find sine 45. Sine 45 degree, we can use any of the triangle. This is 45, this is 45. We can use anyone. So I'm using this. What is sine? Sine is opposite over hypotenuse, which means opposite is 1 over root 2. Opposite 1 over root 2. So if we rationalize, this is going to be root 2 over 2. That is that. So for cos 45 degree, this is 45. Cos is what? Adjacent over hypotenuse. Adjacent is 1 over root 2. It's also 1 over root 2, which is what? Root 2 over 2. You can see that sine 45 is also equal to what? Cos what? Sine 45 is equal to what? Cos 45. Or cos 45 is equal to what? Sine 45 degree. You must note this. Take note of this. It's another important trigonometry identity of or function. So now, tan 45 degree, that is the last one. Tan is what? Opposite of adjacent. Opposite is 1. adjacent is 1. 1 over 1 is equal to what? 1. You can see that now 45 is 1, 1. So that is how we can what? Get the trigonometric ratio of all these three special angles. So I believe we have learned something today, and whenever we are dealing with a problem, or maybe it's an multipurpose exam where we have option that is carrying root 2 in root, that the answer is are in roots, then what we are going to bring to play is ability to what? To draw any one of these and use to find the angle that we are looking for among these three angles. Once we can do that, then the problem will be solved. I believe we will be able to help. So thank you for watching our channel. Please, I will seek your help or assistance for us to do, for you to do what? Help us to subscribe, like, and share the channel. Thank you very much. Bye.